Hello, it's a pleasure to introduce the recent work by our group, which is about a new observation-based clumpy torus model for active galactic nuclei. So in this work, we analyzed the X-ray spectra of a sample of AGN to study the obscuring torus in this AGN. And we select sources from the Swift Bata 100 math catalog. And we select source whose love set column density between 10 to 23 to 10 to 24 per centimeter square. Although Compton-thick AGA is an ideal sample to study the obscuring torus since they are reflection dominated. However, the detection of Compton-thick AGA is significantly biased against. So we choose the Compton-thick AGA to be a least biased sample to study the obscuring torus. We also select sources who has already been observed by NuSTAR, since NuSTAR data is necessary to correctly characterize the spectra of heavily obscured AGN. So finally, in our sample, we selected 94 heavily obscured Compton-thin AGN. And we also compared our results with 17 Compton-thick AGN, which also have NuSTAR data from the Marchesi et al. 2019 paper. And our spectra of the sources are analyzed using the Boros model. So here is the result. In the figure, I plot the law of set column density versus the torus column density of each source. And the black points and the red points are the average value in each different law of set column density beams. And as you can see that we find, firstly, the average torus column density for both Compton-thin and the Compton-thick AGN is Compton-thick, which is about 1.4 times 10^24 per centimeter square. And secondly, we find that the AGN torus is significantly clumpy. We plot in the figure a dashed line, labeling the when their love set column density equal to their torus column density. And as you can see that most of the sources are far away from this dashed line, suggesting that their love set column density is significantly different from their torus column density. We also find Compton-thin AGN are always observed through an underdense region of the torus. As you can see that most of the Compton-thin AGN have their love set column density much larger than their torus column density. However, the Compton-thick AGN are always observed through the overdense region of the torus. In this figure, we plot the love set column density versus the current factor of the obscuring torus. And we find that for Compton-thin AGN, the average current factor of the torus is about 67%, which is much larger than the current factor of Compton-thick AGN. And so since we select an unbiased sample to study the obscuring torus, so we assume that this is also applied to all different types of AGN. So using the information we obtained from previous slides, we built a new clumpy torus model for different types of AGN. So in this model, we assume firstly, the average torus column density is Compton-thick. And the Compton-thin AGN are observed through underdense region, and the Compton-thick AGN are observed through overdense region, and the unobscured AGN are observed through the region which is not across the obscuring torus. The average torus current factor is about 67%, so the unobscured AGN fraction is about 33%. And we also find that the torus is extremely clumpy. However, keep in mind that all this information is about the intrinsic properties of the torus. However, what we usually observe is the law of set property of the AGN. So we use the torus information obtained in the previous slides and a Monte Carlo methods to calculate the law of set column density distribution of the different types of AGN. And here is the result. We also compare our law of set column density distribution with the previous observation. and also the column density distribution used in the previous Asian population synthesis models. And but keep in mind that our column density distribution obtained in this work is only for the local universe. And in Clemson, we also study the Clemson agent. So here is the website for our Clemson agent project. Please feel free to visit our website. And please stay tuned with the Dr. Torus Alba's talk. She will talk about the Clemson agent project in Clemson. And also for the material about this project, you can find on the archive. So thank you.